This is a story about the Lemming Festival. Feel free to pause the video if you need to do any computation or take any notes. As all of you know, today is the Annual Lemming Festival. To honor the Grand Lemming, it is traditional to select a class to immolate. Guess which class has been lucky enough to be chosen for this profound honor? Yes! If each student may select to be immured, enkindled, or defenestrated, how many unique immolation distributions will there be? Well, first of all, understand that it doesn't make any difference what those things mean. How many choices do you have? And let's just say that there are 10 students in this class. Then how many unique distributions will there be? First student has 3 choices. Second student has 3 choices. And from a previous story, you'll recall the fundamental counting principle says you will multiply those together, etc., etc., etc. So the answer will be 3 to the 10th power. If instead of 3 choices you had C choices, and if instead of 10 students you had N students, the answer would be, which is the general way to solve a problem like this. As you may suspect, the entire class is requested to be defenestrated. We're in the first floor, by the way. If the class was defenestrated one at a time, how many possible lineups will there be? Well, what you should do is get the class together, and how many choices do we have for the first honored position? We have 10. Once that person is selected, we have 9 more to choose from. And again, using the fundamental counting principle, that would give us 10 times 9 times 8, all the way down to 1 for the 10 slots. And not only is that exciting, we use the exclamation point to represent the fact that we are multiplying by 1 less number each time till we get down to 1. It's called a factorial. So in general, if you had N students and N slots, it would be an excited N factorial. Now, let's be honest, this is a little far-fetched. A more realistic scenario would probably have 4 students from the class randomly selected to share the honor of being defenestrated. Now, how many possible lineups would there be? Well, again, you got 4 slots. First choice is 10, second is 9, third is 8, and then you have 7. How do we symbolize that? Well, in mathematics, it's sometimes easier, rather than writing all that out, to write it as 10 factorial over 6 factorial, because you're canceling off 6 times 5 times 4 times 3 times 2 times 1. And we often write that as 10p4 because we have 10 items of which we're selecting 4 positions. P stands for permutation, which is the kind of procedure that we're doing here. In general, you have n all the way down to n minus r plus 1. Notice 7 is 1 bigger than 10 minus 4. That's n factorial over the quantity n minus r factorial, and we usually write that as npr. No jokes. Okay, to make the situation even more true to life, we know that the students would not really line up. They would probably be so excited about being selected that they would rush to be defenestrated simultaneously. Since order no longer matters, how many randomly selected groups of size 4 could be selected from this class for the profound honor? Well, first of all, you have to ask yourself, is it bigger or smaller than the answer that we had to the last question? So, for example, suppose we select Annette, Bruce, Carl, and Darlene. Since order no longer matters, they've been counted 4 times 3 times 2 times 1. They've been counted 4 factorial times when order matters, but now that order doesn't matter, we need to divide by 4 factorial. So if we take the previous answer and divide by 4 factorial, we get 10 factorial over 6 factorial divided by 4 factorial, and doing the math, we end up with 10 factorial over 6 factorial times 4 factorial. Kind of interesting how those numbers work, right? So in general, this is called a combination. Kind of unfortunate, since when you're doing your locker, a combination order matters, but in this case it doesn't. You have n factorial over n minus r quantity factorial times r factorial. You notice it's the same answer we had before, except there's an r factorial in the denominator. We usually abbreviate that as NCR, or even better, we have parentheses n over r, because this is used a lot in mathematics. So the more efficient the notation, the better. Immolation is not the only activity at the Annual Lemming Festival. 2 other popular events are the spelling contest and Ring Around the Grand Lemming. Since the largest of the festivals is held on the banks of the Mississippi River, which is sacred to any devout lemming, the spelling contest consists of having each contestant write down as many 11-letter rearrangements of the word Mississippi as they can. Since most lemmings are not too bright, the sequence Mississippi does count as one rearrangement. How many possible rearrangements of Mississippi are there? Well, you'll notice that there are 11 letters in Mississippi. So one guess might be 11 factorial. What's the problem with this? You'll notice that the S's, for instance, are repeated 4 times. So if we're using 11 factorial, we're treating each S as if it's distinguishable. In other words, we can tell the difference between them, which we really can't. So we would have to take 11 factorial and divide by 4 factorial for the S's, similar to what we did in the previous problem. However, there are I's that are repeated and P's that are repeated. So 11 factorial over 4 factorial, 4 factorial, 2 factorial, 1 factorial, because of the repetition numbers of S, I, and P. Notice the M is the only singleton. You can put the 1 factorial there if you want. It's not necessary. In general, if you have repetition numbers, you have to divide by the factorials of those in the denominator. So L being the number of distinguishable letters that you have. Ring Around the Grand Lemming is a sacred ritual in which all the lemmings join paws in a circle and rotate once around the Grand Lemming while chanting, "Where you lead, I will follow." Then the lemmings must reform in a different arrangement and repeat the process until all possible circular arrangements are completed. If there were 1,000 lemmings at the Quad Cities Lemming Festival, how many rearrangements were there and how long did the ritual take? Well, one guess might be 1,000 factorial. Problem is they're in a circle. 1,000 factorial would be if they're in a line. So the lemming that would be in the front of the line would connect with the lemming that would be in the back of the line, if you're thinking about a circle, and they could rotate 1,000 positions and still be in the same circular arrangement. So the answer is 1,000 factorial over 1,000, which is essentially 999 factorial, which means the ritual would take a very, 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 very long time.